This is Module 2 of the laser training, where I will demonstrate how to create drawings for the laser cutter. Drawings can be created in a number of software applications, including SolidWorks and other CAD software, CorelDRAW, Adobe Illustrator, and many others. The Epilog Zing laser is treated as a printer, which means any software application that can print can also be used to laser engrave. You could even use Microsoft Word and laser engrave your next essay for English class, if you think your teacher would appreciate it. Line thickness is one of the most important parameters to be aware of when creating drawings for the laser cutter, because thin lines that are less than 2/1000ths of an inch thick will be treated as vector entities and will be cut, while thick lines, text, pictures, and other graphics will be treated as raster images and will be engraved. Since most of you have learned SolidWorks in ME172, let me demonstrate how to create a drawing in SolidWorks that you can send to the laser cutter. Here's a SolidWorks model of a spur gear. I've also created this SolidWorks model of a rack. These are the two parts that I'm going to be cutting on the laser. And cutting on the laser from SolidWorks is pretty straightforward as long as you remember that the laser cutter is treated as a printer. So we need to create a drafting drawing with views of these parts that we can print to the laser, just like we would do if we were going to print it on paper. And that's done by doing a new, and I'll choose one of the drawing templates. And you'll notice here that I've actually created a template for myself that's called Drawing Laser. And if you went through ME172, you probably have all of these templates already. But if not, I'll post a zip file in the MakerLab iLearn course where you can download these templates. This drawing template is simply a sheet of paper that's 24 inches wide and 12 inches tall and has no title block on it. You'll also notice that in this template, if I go to the options, under Document Properties and Line Thickness, that I have made the line thickness in this drawing 2/1000ths of an inch, indicating to the Epilog laser that these should be treated as vector entities and cut. Now I just need to place views of my parts on this drawing sheet. I go to the View and Layout tab, under Model View. The parts that I already have open will be listed here, but if they weren't open I could just browse for them. Let's place the spur gear first. That brings up this drawing window where I can choose any orientation, a top, a right side, or a front. I like to check this preview box so that I can see what view is going to get placed. So I know I'm not going to place a view from the wrong angle. This is the view that I want to place. I also need to make sure that I'm choosing to show the view with hidden lines removed, because I certainly don't want to laser cut the hidden lines. And I'll also select to use the sheet scale. Let's go ahead and place this view. Now let's create another model view of the rack. Again, I'll show a preview, make sure I'm showing the view with hidden lines removed, and I'll check this box here saying use the sheet scale. Using the sheet scale means that any of the drawing views that I place on this sheet will be scaled according to scale factor for the entire sheet. I'll go ahead and show you how to change that sheet scale factor. I simply find the sheet and right click and choose Properties. This is where I can see the scale of the sheet. In this case it's showing a 2:1. So if I were to laser cut this, my parts would be cut twice as big as they should be. Let's change it to a 1:1 scale. Now if you didn't have the template, that's not really a big deal because you can always just make a few tweaks to any drafting drawing template so that you could laser cut it. One of the important tweaks is to select custom sizing and to indicate that it's a 24-inch wide by 12-inch high sheet of paper, which corresponds to the cutting area of the Epilog Zing laser. Let's apply the changes. Now I can manipulate these in the cutting area the way I want. Now if any of these parts was oriented incorrectly, I could orient them right here. If I right click on the view, I could choose Zoom Pan Rotate. I could rotate the view, and let's rotate this 90 degrees. So I could cut it in that orientation if I wanted to. Let's go back to 0 degrees. Apply that. Now I can also place some text if I wanted to engrave any text on these parts. If I go to the Annotation tab, I can place a drawing note. I'll choose to turn off the leader, since I just want to place plain text without a leader, and I'll choose to center the text vertically and horizontally. Let's place the text, and I'll type in BYU Idaho MakerLab. Now that font's a little small, so I'll highlight all that text. Let's make the font a little bit bigger. Should we make it 24-point font and maybe bold? I could even change the font if I wanted to. And I can move that text so that it's centered here on the part. I can also place picture files. I've created a shortcut tool right here that will insert a picture into this drawing. But if you don't have the tool, it's just right here under Tools, under Sketch Tools, and Sketch Picture. That will let you go browse for any kind of a JPEG or PNG image. Let's select this MacGyver pocket knife image. Here it is. I can shrink it and move it around, position it on this gear the way I want. Once I'm finished positioning it, I could say OK to the sketch picture. And there it is. Now I'm ready to print this. Now I could bring all of the SolidWorks models to the laser cutter and print straight from SolidWorks, but that would require the model of the gear, the model of the rack, and this drawing file. And I think there's an easier way. I could go ahead and save this as a PDF, and then I just need to take the PDF to the laser cutter and print the PDF. So let's save this as a PDF, and I'll call it Rack and Pinion. Now let's go ahead and open that PDF to see what it looks like. Here it is, Rack and Pinion. I like to make sure I'm opening PDFs with Adobe Acrobat Reader. And here it is. But you'll notice because I did this drawing in SolidWorks, and the SolidWorks version that we have access to is an educational license. Look down here in this bottom left corner of the sheet. We place this watermark, SolidWorks Educational Product for Instructional Use Only. That text is actually going to get engraved on our material. But that's alright, because it's not going to get engraved on the finished parts that I want. And there's still a lot more material that could be used productively. And this is just a sliver at the bottom that's now unusable. And I think it is a good reminder that when you're using SolidWorks, it's an educational product and is not to be used for anything commercial. This is now the PDF file that we can take with us to the laser cutter